Hello everyone, I hope you're doing well. So in this video, we are going to discuss the solutions for problem A, B and C for Codeforces round 814 rated for division 2. So let us start with the first problem. So the first problem is chip game, which states that there are two players and there is a board of n into m cells, and in one move you can either move up or you can move right, and you have to make odd number of moves. So this is the condition, that you have to make the odd number of moves only, right? So in this question, there is one more condition, that you cannot move up or right at the same time in one move. Either you can move up or either you can move right. The game ends for you when you cannot make any valid moves, right? So here are two players. The game starts from the this position, the lower leftmost position, and the game ends on the top right position. This is the first observation, that once you reach this particular position you cannot move anymore, right? Now if you work with intuition, you can just find the length of this board. It is A and B. The answer will only be true, or the player one will only win when one is odd and one is even, right? We have two numbers A and B. One of them should be odd, one of them should be even. Then only player 1 will win. Otherwise, player 2 will win. So this is the basic intuition. This you can say just by observation. Now, if you want a valid proof behind this, then it can be this can be said that this is a composite game, right? This is a composite game. Actually, this theory or this proof is not required for this question, as it is just the first question of division 2. So I would not say that the theory is important. It's just the intuition that either one of them have to be odd and the other has to be even. But if you really want to know about the proof or theory behind this, this can be reduced to two simple games, right? The first game can be played on this one, on the height, and the second game can be played on the width, right? And for each of the game we can calculate. For example, there was just one. For example, this was our board. This, we can consider this as our board. So if this was the board, when you are at the position 0 or the last position, you cannot make any valid moves, so the answer is 0. When you are at position 1, you can go from here to here, so the answer will be max of 0. In this case it will be 1. Now if you are at position 2, you can go to position 1, but you cannot go to position 0, because then it will be even number of moves. So for this 2, the answer will be max of 1, right? So this case will be 0. For 3, it will be again 1, because you can now go to position 0. Max of 0, max of 1. So this will be alternating series, right? Similarly, it can be said for this particular series also. So what we observe is, if it was of length 1, if it was like, if the width was n and the height was 1, then the answer would be, if n is odd, if n and 1, then the answer would be player 1 will win, otherwise player 2 will win. But since it is a composite game, these two are stacked together, then the answer will be P1 XOR P2. Then the answer will be A n and 1 or A and 1 XOR P and 1. Because in composite games, what we do, we take XOR of both the games. So this is the whole proof behind this question, that one of them should be odd and the other has to be even, or like they have to be opposite. If one is 0, the other should be 1, so that the resultant is 1, right? So this is the whole proof, and this is from the Grundy theorem and Sprague-Grundy theorem, and it states that player 1 will only win if the XOR of all the simple games in the composite game is non-zero, right? So it will be non-zero only if one is odd and one is even. So this was the whole proof behind it. I don't think you need it for solving the question. You can just looking at the question, you can say like it's just a basic observation. If you have solved many Codeforces contests, then this might come to your mind. But this is the whole proof or idea behind this question, right? So this is the code as I have stated. Like if A and 1, this states that if A is odd, if B is odd, and I have taken XOR of both the operations. If this is true, then the first player will win, otherwise the second player will win, right? So this was the first question. Now let us move to the second question, which is mathematical circus. Yeah. So this question said that an entertainment has appeared in the city, right? So there is a circus, and like there are numbers from 1 to n, right? Now n is always even, and you have to make n by 2 pairs of numbers such that let a and b be the numbers. Let a and b be the numbers in one pair. So the question states that you have been given an integer k, and you have to make the pairs such that a plus k multiplied by b should be divisible by 4. So this should be divisible by 4. Now using simple modular arithmetic, we can say that, like, let me just write it first. A plus k into b mod 4 should be equal to 0, right? We can also write it as a plus k mod 4 plus b mod 4 whole mod 4. Oh, sorry, this was multiplication sign. Should be equal to 0. So since this is multiplication sign, so either this have to be 0, this part, or this part has to be 0, right? Either of them can be 0 or both of them can be 0. This is our choice, right? So we can make pairs such that the first part, let us call it this part A, let us call this part B. We can make pairs such that A is 0 or B is 0 or both of them are 0, right? Now thus the second observation, for example, if k is equals to 1, right? If k is equals to 1, there is one very interesting thing we can do. There's one very interesting pattern we can form, right? So that pattern can be, uh, take the first number as odd like 1 and the second number as even. So these are just two adjacent numbers, right? If we take them and add 1 to it or any odd number to it, so this was already an odd number, and if we add an odd number to it, so this will become an even number. So if the first number has become an even number, it means it is a multiple of 2. The second number is also already an even number, so this is also a multiple of 2. If we multiply both of these numbers, like this was going on, a into b, if we multiply both of these numbers, it will become a multiple of 4. So in every case, if k is odd, in every case we can just take adjacent numbers, 1 2 3 4 5 6 7 8. This will always work in any case. This is because of this proof, right? But what if k is even, k is some number 2? Now the next thing we need to do is, what we can do is, if k is even, now it can be like k mod 4 can be either 0 or k mod 4 can be either 2. So these will be the two cases that will arise when k is even. K mod 4 can be 0, 2, sorry. So when k mod 4 is 0, in this particular case, the answer will be always no, because there will be no way to convert this odd number into some multiple of 4. Because if this is odd, or any number, like if I take it as odd and k mod 4 is 0, it means it is a multiple of k. So if I take it, 1 mod 4 will be 4, and 1 plus k mod 4, so sorry, this is 1 mod 4 equal to 1, and 1 plus k mod 4 will also be equal to 1. So in any case, if I add any amount of k, this number will never change. So if k mod 4 is 0, the answer would be strictly no, right? And the last case that we are left with is when k is even and k mod 4 is even. K mod 4 is 2. And for the last case, when K mod 4 is 2. So this is the final case when our answer can be yes. Right. So how can our answer be yes in this case? Let us take an example 6. Right. So first we take all the odd numbers. Like let me write them down. 1, 3, 5. So these are all the odd numbers. Right. And let us write all the even numbers which are not multiple of 4. So those numbers can be 2, 4, 6. Right. So these are all the numbers, and we can write the multiples of 4, 4 and only 4. Right. So these are the three categories we can divide our numbers. So these are all the numbers from 1 to 6. 1, 2, 3, 4, 5, 6. The first category is the all the odd numbers. The second category is all the even numbers which are not multiple of 4, and the last category is multiples of 4. So I'll tell you how to make the pairs. First of all, you can use these numbers because these are even numbers and they will always, for example, if I take 6, they will always give me 6 mod 4 2, 2 mod 4 2, right? They will always give me 2. So if I add k, and k mod 4 is also 2, so if I add k to this number, it will always give me a multiple of 4. So it will help me to bring this particular part as a multiple of 4, and I can make a equal to 0, right? So I can take 2 and I can take one number from the odds list, 1. Then I can take 6 and I can take one number from the odds list, right? 3 will be here. Now this is already a multiple of 4, so this will help me bringing b equal to 0 because it is already a multiple of 4 and 4 mod 4 will be 0. So I can write it as 5. I'll take the third odd number from here, and I can write 4. So it's so this will be the final answer. This will be a valid answer for n is equals to 6 and k is equals to 2, right? For k is equals to 2 it will work, or for k is equals to 6 it will also work. For all k mod 4 equals to 2 it will work, right? So you just had to figure out some cases, and after figuring out the cases you just had to print it, right? So I'll show you the code for this question. So I have what I have done is, if k is odd, like I have explained you in this case, if k is odd, we can always find the answer by printing the adjacent elements. So what I have done is, I have just run a loop from 1 to n, and I have added 2 to I every time, and I have printed I and I plus 1 together, right? We can always print the adjacent elements. Now if k is even and k mod 4 equals to 0, right? So k mod 4 is equals to 0, it means that when we divide k by 4, the remainder will be 0. So in this case the answer will be no always, and I have already explained you why. So we actually don't need this particular condition. I just wrote it down that time, but you actually don't need it. And in this condition I just checked if n is even, but n will always be even as it is given in the question, right? But if n was ever odd, this should print no, but you don't require this condition because n is always even. Now in this case what I do is, I take c, the first odd number, I print yes, and what I do is, starting from 2 I print all the even numbers which are not multiple of 4. So 2, then 2 plus 4 6, then 6 plus 4 10. So I'll print it I, and I'll print c, and I'll add 2 to c. Why am I adding 2 to c? For example, the first odd number is 1, the next odd number will be 3, then 5, and this will go on. Again, I am printing the odd numbers with the multiples of 4. I am first printing 4, then 8, and as you can see, I have written c here, and the second number multiple of 4 I here, and I am constantly adding 2 to c. So this is how I did the second question. I hope you were able to understand it. Now let us quickly move on to the third question.